Welcome to part two of this Principles of Natural Systems lecture. I'll get that out in the end. Yeah, so it might seem an obvious statement. What is a forest? What do they look like? What are they made of? Well, I want us to ask some fundamental questions. So I do want to sort of, and that's the purpose of this lecture, really. I guess, is to get this idea of nature's our teacher. Let's, rather than just taking it all for granted, can we really delve into it and can we understand that better and the processes behind it? Because that's what permaculture is informed by. So yeah, there we go. Let's ask fundamental questions. No questions too stupid. Let's try and understand what we've seen going on around us all the time. Yeah, so here's a sunken boat. I think this is in Africa. I've forgotten where this photo was from. It's not mine. I just picked it up somewhere. But what interested me, of course, is look, there's a boat. It's run aground. It's been abandoned. And in time, a forest has grown there. Nobody planted it. Nobody planned it. Nobody went to, bought anything. It's literally spontaneously assembled itself through this process of succession on the on the deck of this ship. So, the first thing we can say is, look how with nothing but the wind, birds and seeds randomly, moving through a system, the forest has assembled itself. And nobody had to do anything. And that's to our permaculture mind is really interesting, because you think, well, in what way can we understand that process, that self-assembled, it's a diverse, abundant ecosystem, and can we apply those processes to our own growing processes? Can we work in harmony with that thing that nature wants to do automatically? So let's take that in mind and hold that in mind, that nature does this all by itself, but it's a process, and we can learn a lot from observing that. So this is a photograph of moss, that plant we talked about in the first lecture, and this is is actually growing on the corner of a car park, of a tarmac car park. I was actually waiting for someone to pick me up after work to get a lift home, and I was just thinking how this flat car park, but wasn't quite flat, and the lowest point of it, where water had gathered and where materials had sort of obviously been carried by that water, had become a carpet of moss. And when you're looking at it, you can see there's little brown speckles, these little things all over it, the seeds of a birch tree. You may not know the birch tree, but it's a primary colonizer tree. It has very small seeds which blow around in the wind long distances, and if it gets a chance to grow, it grows very quickly. So it's a pioneering plant. And look how these pioneering plants have teamed up together. We've got the moss, which has helped hold around some moisture, build up some humus, create habitat for soil microbes, and to begin that process. And then blow in the seeds randomly. Some might take, some might not. They might not be able to achieve their full potential, but they will live and die, and they'll contribute to the building of that soil and a building of that ecosystem. And so you can imagine how that's kind of what happened on that ship over time that we were looking at. Okay, so thinking about succession, and we're thinking about how different species of plants and different organisms might work together to sort of build an ecosystem, to slowly fabricate it. This is a picture from North Wales, and this is the land which has been completely colonized by birch trees, the same ones of the seeds that I just showed you. And you can see how that dense growth of birch trees, with those millions of seeds that they create, creates almost a blanket which has covered this whole hillside. I'm seeing forestry there, which would be a kind of a tree farming, and I'm wondering whether this land had been abandoned and the trees have grown back or spontaneously. But this looks like natural regrowth, and and in a certain way, if you take a few steps back, sometimes when I look at this picture, I think, gosh, really, these trees are doing the same job as the moss, but at a bigger scale. And the moss might only be a few millimeters high, but these trees are maybe, 8 or 10 meters high. And birch tree, it has quite a fast growth cycle. It grows quite quickly, and then it falls over and dies, and its wood rots very quickly. So it's part of this successional process of building what ultimately become increasingly more complex ecosystems. So here's another interesting thought, that certainly as the succession develops, the number of species in the system increases. It might ultimately wane and drop off a little bit as the system matures, but that depends on other factors. But it's just interesting, again, so just observing. Look how nature likes to cover bare spaces. When it does that, it creates a seed bed, which then the next sort of wave, successional wave of plants can come in. And of course, in this example, in the moss, there might be lots of habitat there for, bacteria and other sort of microscopic organisms, very small micro arthropods, maybe living in that. And then as the scale grows, then perhaps there's more room for mammals, for birds, for reptiles, for amphibians or insects, of course, and everything else. So think about how an ecosystem is developing, and it's creating niches and habitats for many more other species. And then we talked about how moss can absorb and hold water. So think how that might slow down the passage of water, but only to a certain extent because it's a very small plant. And then contrast that to this young woodland and think about how much water that in turn is holding. And slowly, obviously, through evapotranspiration, returning that moisture to the air, humidifying the environment, and ultimately creating more rainfall. So we're interested in those plants that perform these functions in succession. And they'll be different in different climate zones and different places. They might have different names, but they're performing the same functions. So if we can understand the characteristics of a plant, it grows very quickly. It can grow in very poor soil. It decays very quickly. It feeds lots of insects. These are characteristics of plants, and often a pioneer plants will have these very specific characteristics. So again, these are things that we can begin to observe from nature and ask ourselves these questions as we move around and see what we see. Okay, here's a kind of a random observation. Walking through a town in England, and this is a car park or something like that. And look, it's got a sort of a brickwork pavement, and it's actually been abandoned. The gates were locked. I don't know why, and it hadn't been used for quite some time. And there it was, just a forgotten, quiet corner of somewhere. And I was looking through the gate, and I thought, look how interesting that is. How we can see again the succession, the same process that we're talking about. Here's our mosses and lichens, and we could look how the mosses have grown in the cracks between the bricks, and that's clearly because the mortar between the bricks can hold more water. There's a little bit more opportunity for the plants to get started. And so again, the succession starts, and that moss lives and dies, opens up the opportunities. And then we have another plant moving in. We have this herbaceous plant moving in. And look, it obviously can grow in quite poor soil. It's managed to grow to flower. And as that lives and dies, starts to contribute to soil building. I mean, look, we go over to the other side of here, but as we go further back, you can imagine also wind blowing material. So there seems to be an aggregation of material here. And on the right-hand side, we're getting grasses coming as well. So step by step, this succession, enabling one set of plants, enabling another set of plants, enabling another set of plants. And think about how those plants are responding to the literally microclimate conditions of where they're at. There's a very subtle difference between the surface of the brick and then the gap where the mortar is. And that's where the plants are growing. So I always encourage people to pay attention to what we call microclimate. There's subtle differences, even in a very small, within a locality. And again, through permaculture design, we tend to try and create microclimates so we can create a range of conditions that suit a range of different organisms. Look how we might even be inspired and copy from that process. This is a porous clay jar that's been sunk in the ground, which could be filled with water and would slowly wick moisture into the soil and nourish the plants around it. That's sort of modeling on the accidental thing that's happening in the gap between those bricks. And just giving an example of how these subtle things that we're seeing around us might inform us and might inspire us and give us ideas of how we can allow these natural processes to inform us, and we can then apply them into our own designs and into our own techniques. Successional plants, interesting plants that grow in very particular conditions. This is a plant, I don't know if you have it in East Africa, but again, you might have similar plants that fulfill the same function. This is called greater plantain. It's a very ancient plant. These spikes here are flower spikes because it is a wind pollinated plant. So that means that this plant came along before insects, older than there were insects. It's a medicinal plant. It has very useful properties here, amongst other things. And typically it grows on compacted ground and on pathways. And it's something that we associate with, it grows in gateways and on trackways and things like that. And it's a useful medicinal plant, but that also helps repair damaged ground and can provide obviously nutrition and health-giving benefits to grazing animals. So it's a tough, pioneering plant that can grow in tough conditions. Here's another plant that can grow in very nutrient-poor soils. One of the key nutrients that plants need, of course, is nitrogen. And some kinds of plants, special kinds of plants, can fix their own nitrogen. What they do is they build a relationship with a special soil bacterium called rhizobium, and a bit like within the fungi algae relationship in the lichen, these soil bacteria can trade nitrogen, which you can access from the soil atmosphere, and trade that for sugar with the plant. And we call this family of plants legumes. And we can generally identify them because their seed pods and their flowers have the same pattern. So we're seeing here this pea and bean shaped pod. And we know that also pea and beans are also leguminous plants and can fix their own nitrogen. So there are tough pioneering plants that can grow in very poor soils. They can start to create and soften and create the right kind of conditions. And there's other kinds of plants that can come along and literally start building their own nitrogen. And as those plants live and die, they are soil building plants. So we can see how nature begins to assemble itself with these interesting, unique, and pioneering plants start building the system. We can't go straight to forest. We've got to work our way up through the succession to get there. Again, this is a woody herbaceous plant, so it's a woody plant, so it will maintain all year round and start to create more cover and contribute more to the succession. So a young, fast-growing tree that we have in temperate Western climates is called the elder tree, and it has these little black berries, which are very juicy and really popular with birds. Now, elder seeds are everywhere, and so once the conditions are right, certain kinds of trees, elders, also mountain ash. This is another plant with a fruiting tree that will grow. It's a pioneering tree, will grow in tough. This one's more a mountainous tree. This one will grow more in softer ground. But what's interesting about these plants with these lots of fruits is they're highly mobile, because obviously they're catching a ride with the birds, and also as they start to grow, they attract the birds. This is the bramble, the blackberry, and again, this is a trailing plant, spiky, spiny plant that can grow in really tough conditions. And what it does is it grows into the sunshine. It grows towards the sunlight and sort of grow up and towards the sun, and then fall over. And where it falls over and touches the ground, it roots again, and then carries on and sort of hops its way around. So it works on the leading edge of the succession, and then creates a tangle of its thorn and thorny briars, which again actually push out grazing animals and allow more chance for trees to get established. And what's interesting about all these fruiting things that bring in lots of birds is that encourages the cycling of phosphate. And that's the P in NPK, and obviously phosphate is in bird droppings, and the more birds are interacting with the system, the more they start cycling phosphate, which makes it available to the roots of plants, and plants need phosphorus for good root development. So we can see how actually the ecosystem itself starts assembling the nutrients, assembling the components that it needs to build itself. This is a rose, a briar, another element that we might see, another climbing, rambling, spiny plant that might contribute a lot to the development of a forest system. As things are growing, they're also dying. And we mustn't forget the importance of the fungi in the system. And one of the things that fungi do is they're breaking down dead organic matter and absorbing it and digesting it. And in the long term, then making those nutrients available to the next generation of plants. They're starting to complete the cycle and hold on to the nutrients that the system has built up. So we've seen how nitrogen, phosphorus has come into the system and starts to be cycled and held on to. And obviously the carbon now is building up in the soil as the first generation of trees are absorbed and die. And then look at this young woodland. I took this picture also in Scotland some years ago. We're seeing the forest floor is flooded with a plant which we call bracken. And bracken hyperaccumulates potash, which is the K in NPK. So these plants need many other nutrients as well, trace elements and trace nutrients, but to kickstart the system, we need N, P, and K. So, and there are certain plants which if they don't necessarily generate it, is they can accumulate it, and then as they live and die, make it available to other plants. So the nutrients that we need, or that are needed to build the forest, are actually, if you like, moving, cycling through nature all the time. And as we attract life to our abandoned ship, slowly, those nutrients get trapped up in the cycles and the systems that are going on there, and that the capacity, the potential of that ecosystem develops, so that in time it can accommodate more and more complex plants and animals and create more and more habitat. And more importantly, it can hold more water, and it can convert more of that solar energy into biomass. And that's what we're looking for. That's what we're always trying to achieve. So So many lessons to come from just observing how nature works on its own accord. Think about climbers now. As our forest develops, we've got younger trees slowly start to fill up the space. As those trees develop, they'll shade out the understory, and that bracken will become much thinner, and just the occasional plant maybe. But they'll be there waiting. If a tree falls down and suddenly there's light on the forest floor again, or in danger of that soil being eroded, then the bracken will flood in and mop up those nutrients and return it back to the system again. So the more we look at these systems, we realize that there's different elements that are doing different jobs, but they all contribute as a whole to the larger system. And that's the thing. Again, these ideas of synergies, symbiosis, mutually beneficial associations, that's what we're interested in permaculture. That's the raw material. So always, I mean, looking at natural systems, try to look at that with a certain kind of curiosity. So climbers, think how climbers rather cleverly link the understory, the herbaceous layer and the plants. They climb up through the trees and capture sunlight wherever it's available. I thought this was an interesting picture. We'll just pause here for a moment. Is someone's been clearing. This was in North Wales. It doesn't really matter where it was. Someone was clearing in the woodland, and they've put up a pile of dead sticks of what we might call brash, twigs and sticks that they piled up. Maybe they left it there to create a bit of habitat for other organisms. I don't know. And then what has grown on it is a bindweed, a convolvulus. It's a wild climbing plant, and look how it's flooded in, and it's fully occupied the sunny side of this pile. So, in the biggest leaves, the strongest leaves are in the most optimum position, and we can see there's the sunshine on this side of the pile. Whereas on the other side of the pile, there's almost no growth at all. There's some. It's trying. It's still some deflected, diffused light, but they look how there's much fewer, and how much smaller and weaker they look. So we're seeing microclimate, the subtle differences. As farmers and gardeners and growers, we want to understand the subtle differences between one place and another and work with it. And there are different characteristics to the sunny side and the shady side, and we can make both of those work to our advantage if we are thoughtful in how we approach things. So little things there in nature that we might just see, accidents, little things that have maybe happened, that is somehow helping us, inform us, and understand, see those processes that are going on around us. It's interesting to think what a mature old growth forest might look like and what that might tell us. So it's going to be a mixture for a stable long-term system. It's going to be a mixture of, you're going to have some very old canopy trees, maybe live for hundreds of years. And every now and again, one of those big trees is going to fall over and die. And that will trigger lots of young trees to have their chance to try and grow quickly and, capture that light. And there may be herbaceous plants that just grow for a few seasons. Again, that might grow and cover the forest floor. And then as the trees grow back, they might be shaded out again. So you can think about this sort of rolling conditions. And so here's a characteristic that many trees have, and especially the broadleaf tree varieties, is that you can imagine that a seedling contains, the seed of a tree contains enough energy for the tree to sort of grow up to a certain height, set its first true leaves. And then if it's growing in a woodland, it's not going to grow any further. It's not receiving enough sunlight to get up into the canopy. So it's just going to sit there. And if its opportunity comes, which it might not, but if the opportunity comes and a big old tree falls over, then that's going to trigger all these young tree seedlings to shoot up and try and outcompete each other to gain the light, to become the next generation of tree. And So it's important to note is that trees have this ability in their juvenile stage when they're young to put on a growth spurt. It's very rapid and it represents a very efficient ratio of conversion of sunlight into the biomass of the tree. So just bearing that in mind, let's look at this traditional system. I'm sure all of our ancestors would have done this. This is what we call coppicing. This particular tree here is a chestnut, and traditionally it's been used in farms and stuff around in the temperate West for fencing and fence posts and gates and lots of farm structures. You can use it in all sorts of different building projects. It's a very useful wood. It splits very easily, so you can make uniform cuts with it, pieces from it, and so forth. It's easy to work with. So this is a carefully managed coppice, and what we're seeing here is it's been cut in blocks, and you can actually see that this area here in the foreground was all cut down to the base of the tree, let's say the previous year, and it started to grow back. And critically, when it grows back, it grows back with multiple stems, not just one leader, but multiple stems. And because it's all been felled in a block, so there's full sunlight arriving on the forest floor, these young trees are triggered to behave just like they were juveniles, just like they were that young seedling on the forest floor, and they grow back really quickly and accelerate up to a certain height and then slow right down. And once people had made that observation about that's the way that certain trees grow, is we realize that that's a very sustainable and very manageable way to produce timber, so wood for energy, for building, for construction, for fences, for all other reasons. It is a very, very efficient way of doing it in a very sustainable way. And of course, when you harvest these coppices, you cut them all off. It doesn't kill the tree. It stimulates the tree to grow back faster. It actually makes the tree youthful again. And the only thing is to bear in mind is that they need to be in full sun, and you need to protect them from grazing animals, so that obviously they're vulnerable to be grazed off when they're young like that. But once they're above head height of the animals, grazing animals, then of course they're away and they're safe. So the lots of the woodland that we have in the UK would have been managed like this for coppice. And of course, there's many advantages of working with wood in this way, because it's a continuous process. The roots remain intact, so the plant's still always photosynthesizing and still building its relationships with soil microbes, etc. You can harvest it with hand tools. You can carry the wood on your shoulder as a bundle, and it's going to constantly regrow. So all of these ideas, beginning to have an empathy for about how forest works, how succession works, thinking about this process of symbiosis, and starting to get a little feel of how perhaps natural systems might work. Okay, so I'm going to call this the end of part 2, and in the next in part 3, we're going to look at food forests. Is a bringing together of the idea of understanding what forests are and how they work. We'll carry on that exploration, but we'll also sort of weave in the idea of, well, and also, can those forests provide yields for us humans? Like, we don't eat trees. How can we adapt and work with these principles in ways which they become productive for us? And again, by looking at this, I hope I'm giving you a clear insight really into where we're going and how permaculture might actually be very, very useful. Okay, see you for part 3.